Welcome to this eLearn security video training lesson on maintaining access and persistence. In this video, we are going to see techniques that allow us to create persistent connections with the exploited machine. Persistent means that we will be able to connect to the remote machine anytime we want, even if the machine is rebooted or patched. To do so, we can try to gather credentials to access remote services such as RDP, SSH, VNC, VPN, and so on. But we can also create and install backdoors on the machine, create new users, edit current services, or even install new vulnerabilities on the system. It's worth noting that some of these techniques are more invasive than others. Moreover, you should always remember to clean up your traces if it's no longer needed. Let's start interacting with the remote machine. We've already exploited it, and we already have the highest privileges on it. Indeed, if we run getuid, we can see that we are running with system privileges. One of the first things we have to do when we obtain access to the machine is to make the current session stable. For example, if we were able to exploit a web browser vulnerability, we may want to immediately migrate to a different process. In this way, if the user closes the browser application, we won't lose our connection. Let's check all the processes running on the machine with the ps command, and then get the process ID of the current session. From the output, we can see that we are running on the following process. Therefore, if the victim terminates this process, we will lose our session. Let's try to migrate to a different one in order to hide our session. Since we're running a system, we can migrate into almost all processes. In our case, we will migrate to svc host. Let's copy its process ID and run the migrate command. As we can see, it works, and we are still running with system privileges. Let's now start with our persistence process. The first thing we want to do is retrieve the password hashes from the victim. This can be useful for different purposes. We can crack the hashes and discover credentials for services running on the machine, but we can also reuse the password hashes to run attacks such as pass the hash. Notice that we can use pass the hash to gain access to this machine, but also other machines in the network. There are different Metasploit commands and modules that allow us to gather this information. The first we're going to use is hashdump. As we can see, it returns the users and the relative password hashes. Since cracking the password hashes is out of the scope of this video, we're not going to do that. Instead, we will try to reuse the hashes and see if we're able to remotely access the machine via pass the hash. Notice that hashdump is not the only command that retrieves this information. Indeed, we can use the post-exploitation module named smart hashdump to automatically gather the hashes and store them locally. As we can see from the output, the hashes have been stored both in the database and the loot folder. If we go back in the Metasploit console and run the creds command, we can see the credentials just gathered. The same is true if we run the loot command. Now we have the hashes. Let's try to exploit the machine via pass the hash. If it works, we will have our first persistent way back to the machine. Let us select the psexec module and configure its options. The options we need to set are the remote host, the username, and the password. Let's start setting the remote host with the following command. Then let us set the username to ELS and the password with the hash gathered before. If we run the exploit, we can see that we receive the error status access denied. This usually happens when we do not have access to administrative shares. Since we already have a session on the machine, we just need to set a registry entry and the module will work fine. The command we're going to run is the following. The reg command can be used to manage the target machine registry. In this specific case, we're telling Metasploit to set the entry at the following path, with the following value name, type, and value. Let us copy and paste it into our Meterpreter session. The command succeeds. Let us now go back to the psexec module and run it once again. It works. We now have our first persistent access to the machine. Notice that if the user changes the password, we will lose our access. In order to avoid this, we can install a keylogger, but we can also add a new user to the victim machine. Let us now see how to create a new user and enable RDP. Different from the previous technique, we will have graphical access to the remote machine. Right now, we do not have the plaintext passwords of the remote users. Therefore, even if we enable RDP, we will not be able to establish a connection. Although we can use tools like Mimikatz or Windows Credentials Editor to get the plaintext passwords, we're going to create a new user on the machine. In this way, we'll be able to access the machine both via PSExec and RDP. There are different ways to add a new user on the machine. We can use Metasploit modules and script, but we can also open a shell on the machine and use the netuser command. The script we're going to use here is getGUI. As we can see from the help manual, depending on the options we set, the script can automatically enable RDP and add a new user on the target machine. Before running it, let's verify if RDP is enabled. We can do this by running an nmap scan or checking enabled services from the Meterpreter session, or simply try to establish an RDP connection to the victim. Let's use the last option by running the following command in a new terminal. As you can see, nothing happens. This means that RDP is not enabled. Let's go back to Meterpreter and use the getGUI script. We're now going to use -e to enable RDP and then -u and -p to specify the new user account credentials. As we can see in the output, RDP is now enabled and a new user has been created and added to the two following groups. Moreover, the script automatically set a rule in the firewall. Let's try the RDP connection once again. This time, let's also add the username and password in the command. It works. As we've seen, thanks to a very simple command, we're now able to establish an RDP connection to the machine. The last technique we're going to demonstrate is how to create and install a very simple backdoor on the target. There are a lot of free tools that allow us to create sophisticated backdoors. What we're going to see in this video is how we can automatically do it with Metasploit. Let us set the Meterpreter session in the background and search the keyword persistence. As we can see, it returns a few modules. The one we're going to use is the following. Although it will install a very simple backdoor, it will work for our testing purposes. Let's select the module and display its options. We just need to set the session ID on how to run the module and the startup type for the persistent payload. We can choose between user and system level. Since we have system privileges, let's set the startup parameter to system and then set the session to 1. We'll leave the other options as they are, so that Metasploit will automatically generate random data and values. The last thing we want to set is the payload. As usual, let us use Meterpreter reverse TCP and then set the local host and local port parameters. In this case, we're using a random port, but during real penetration tests, you will want to use command ports such as 80 or 443. The same for the local IP address. In our lab environment, we are within the same network of the target. If we were outside, we would have used a public IP address. Let's run the modules and see what happens. From the output, we can see that the backdoor has been installed on the remote system. Now, every time we want to connect back on this machine, we will just have to set the handler module with the same payload option set here. Moreover, notice that this backdoor will persist even after a reboot. Let's try and see if it works. First, let's select the handler module and configure its options. We will set the payload to Meterpreter reverse TCP and then the local host and the local port set in the persistence module. Now that it's configured, let's run the module in the background and then reboot the victim machine. Of course, the active session died, but we don't really care. We should be able to get a new session in a few seconds. Here indeed, we can see that the backdoor works fine, and we now have a new session on the victim. As we've seen, there are many different techniques that we can use to maintain access on the exploited machine. We've only seen a few of them. We strongly suggest you try different combinations of the techniques, manual installation of backdoors, and so on. This concludes our training lesson on Maintain Access. Thanks for joining us.